My name is Brian Slator, and I'm here representing the Center for Science and Math Education and the Department of Computer Science and the World Wide Web Instructional Committee, which is a research group that works on immersive virtual environments for education and is a client, I suppose you'd say, of Cyberinfrastructure. I have a couple of slides here just sort of demonstrating an application that we've worked on. And I'll press a button, I think, here. With any luck, that shows you. So what we have then is just a few minutes worth of information here about an environmental science game that we've developed at NDSU. The idea here is that one has a learn-by-doing experience. Multiple users arrive at a virtual space. They are given tasks to perform, problems to solve. And as you can see, this is in this environment, we would be entering a world filled with water and disease and environmental problems. And the idea is that we can learn environmental science by sort of being a detective in this environmental world, and at the same time learn things, well, environmental science as well as some chemistry and some math and statistics, all sort of bundled together as a learning experience. So what I have then is just a couple of slides showing what this game looks like. We're in a world where you can see there's a river to explore. We are able to capture, to make readings, capture water quality data. It's assembled in a table that you can see on the right there. There's others there with us, so it's a multi-user place. We can interact with others and problem solve in groups. Our data gathering it can be displayed in graphical form. So you can see here as we're moving down the river, the phosphates are declining or reducing, but there's a point at which arsenic is sort of being introduced into the water supply, and so as part of this discovery game, well, this is sort of one of the things that we call to our attention, and there's a point at the river that we would go investigate to learn more about why there's arsenic in water and whether that's related to the dead animal fish life. Meanwhile, not that it's a theme or anything, but we have a deceased animal in a lake, and so we've discovered this at a particular point in the river, indicated to us by the data. And on the right, we have a kind of a reference library, and in the lower right, there's I believe that's a picture of a gray crystal that's one of the forms of naturally occurring arsenic. And so as we explore this world, we are learning about this, learning about things. So we've introduced this in a couple of places nearby. These are students drinking the knowledge of science over in West Fargo. And and we're doing our best then to try and make learning entertaining and to make learning engaging and fun. Those are my thoughts. Doctor, are there any questions?
Dr. Schwert, you have something?
Good morning. I'm Donald Schwert from the Center for Science and Math Education at NDSU. And I was asked to speak a little bit about the North Dakota STEM Initiative. The North Dakota STEM Initiative was in 2009. The North Dakota legislature approved $1.5 million of funding to be distributed among the NDUS institutions, the four-year and research universities, to enhance STEM outreach from each of those campuses into the K-12 communities, as well as to network the efforts of these 6 NDUS institutions together in terms of a coordinated STEM approach across the state. And the program, after its launch in 2009 and into 2010, I would say has been highly successful in terms of those efforts. The problem now is that we're hitting a bump in the road with the 2011 legislature, and so whether the momentum can be carried forward or not is a little bit uncertain at this point. In terms of what we are doing from NDSU, help me, Kim, please. Thank you. In terms of what we're doing from NDSU is that we decided to leverage these funds into hiring the first STEM engineering expert in terms of K-12 outreach in the state. And so that position then was brought into the College of Engineering and Architecture as a person who's cross-appointed then with the School of Education and with the College of Engineering. And with the ultimate goal that he would be working in development of an engineering-centered curricula with K-12 across the state in terms of engineering-relevant modules that could be applied in all classrooms at all levels from K to 12. As well as it's important to capture the interest of science and engineering and technology and mathematics with young students, and so these funds then went to support then efforts during the summertime here at NDSU in a program called STEM Kids. North Dakota teachers are starved for professional development opportunities in STEM, and so funds out of the NDSU component then went into teacher development. And of special importance is bullet point number 4 here, is that we used a component of the NDSU award to help institutionalize a program that's called GRASSES. GRASSES it was initiated as a National Science Foundation GK-12 program where students, STEM students, undergraduate and graduate, were brought into the K-12 classrooms to work with teachers and to work with students to develop relevant modules that could be applied in engineering, mathematics, and science into those classrooms. The program was renewed again by a second NSF grant. You're allowed 2 under the same component in there, and then you are expected to go into an institutionalization mode. That's what we did with significant support then coming in from Fargo Public Schools and from West Fargo Public Schools, as well as the Southeast Education Cooperative. And to speak a little bit more about what goes on with GRASSES and to give an example of how GRASSES fits into the Cyberinfrastructure model, I'm going to introduce Kim McVicar, who's Project Director of GRASSES.
be brief. As mentioned, my name is Kim McVicar, and I manage the Grasses project here at NDSU. Currently this year we have 14 students placed in areas, high schools and middle schools, to deliver enriched curriculum. And several years back we had a really unique experience where one of our fellows who was placed at Ben Franklin Middle School here in Fargo was part of an Antarctic expedition team. And as part of his experience within the school, prior to leaving in October, he worked with the students to prepare them for what they'd be doing in Antarctica. And then while he was there, communicated on a regular basis with them via a website and continued to blog. And we also then did a distance experience where the scientists at McMurdo met with the kids at Ben Franklin, and this slide shows that experience. We had a live connection from Antarctica, and the students could ask the scientists questions directly. So this is just one example of the potential that we have utilizing our human resources, which is our talented students, placing those students in the classrooms, and then finding novel ways of connecting real science to the K-12 classrooms, and utilizing the cyber infrastructure if possible. Another way that this can be done is accessing large data sets that might be held on a server at the university that wouldn't normally be accessible in a high school classroom, but our students can link those students with that and utilize those for research projects at the classrooms. So, do you have more on that, Dr. Schwert? Are there questions about grasses?
I think one of the points I'd like to emphasize here is that what Kim just described here in terms of this Antarctic connection here was leveraging an NSF research grant that dealt with Antarctic research with an NSF GK-12 program with the state's cyber infrastructure network in here, and that linkage was made possible thanks to all this work that goes on here in North Dakota.
Presentation.